All right, hi chemistry class. We're going to practice balancing some equations again. In order to use an equation in chemistry, an equation must be balanced before it can be used in chemistry. And the first method is called the box method. This is a good method for beginners. So let's go ahead and do that. So here we have an equation, and we are going to balance that. First thing you do is take each of the elements and write them out separately. So in the first element, there are two vanadium atoms and 5 oxygens. Then hydrochloric acid, HCl, there's 1 hydrogen, 1 chlorine. And then on the product side, on the right side, you have 1 V, 1 O, and 3 Cls. And finally, water, you have 2 H's and 1 O. So what you do is you just pick something to start balancing. You never start with something that appears more than once on the same side of the arrow. So oxygen appears more than once on the same side of the arrow, and so you're definitely not going to start with that. In fact, you leave that until the end. So of the other 3 elements, you can pick any one you want. We're going to start with vanadium. So we see that we have 2 V's on the left and 1 V on the right. So what you do is you simply add a box to the side that has the least of the element you're trying to balance. So we need to add another box of vanadium there. And there you go. You have 2 boxes. Now you have to add everything that's in the box, not just the V. So now you have 2 V's on the right and 2 V's on the left. So the V's are in balance. Let's look at the chlorines. We have a whole lot of chlorines there on the right. You have 6 of them in all. So if you're going to balance that on the left-hand side, you only have 1 Cl on the left. So you're going to have to make 6 of those boxes. So we're going to go ahead and do that. So now we have 6 chlorines on the right and 6 chlorines on the left. So in doing that, we also created 6 hydrogens on the left. On the right, we have 2 hydrogens. So we need to multiply that by 3 to get up to 6. So we're going to add 2 more boxes there. So now you have 6 hydrogens on the right, 6 hydrogens on the left. So we balance the V's, the Cl's, and the H's. And as you look at the O's, they manage to fall into place. So you have 5 on the left and 5 on the right. So everything is in balance. So the coefficient in front of each of these compounds is simply going to be how many boxes you see below it. And there it is down there at the bottom. So that's how you would balance that equation using the box method. All right, the second method is the standard way to balance a chemical equation. It's the way you eventually want to do. The box method can be take up a lot of space. It always works. That's a good thing about it, and it's good for beginners, as I said, but you want to learn to balance this way. So you take each of the elements and you write them down below the arrow. So we have a V, an O, an H, and a Cl. And what you do is you count the number of atoms on each side, and you go ahead and place that next to the appropriate letter. So if we look at the vanadium, the V, we have 2 on the left and we have 1 on the right. Oxygen, we have 5 on the left and we have 2 on the right. So you have 1 in the VOCl3 and you have 1 in the H2O. All right, next is hydrogen. You have 1 on the left and you have 2 on the right. And finally, there's chlorine. You have 1 on the left and you have 3 on the right. Okay, so now what you want to do is look for one. Again, avoid the oxygen because it appears more than once on the right side, or on either side, but on right side in particular in this case. You want to avoid it. And then you want to pick something that's not already in balance. Nothing is in balance here. So we're going to pick something that's simple. And again, we'll pick the V, the vanadium. Okay, so what we need to do is, if we want to get them in balance, we have 2 on the left and 1 on the right. So we're going to go ahead and put a coefficient out in front. You cannot change the subscripts. Okay, those little numbers, you can't change those. You can only put a coefficient out in front. So we now put a 2 out in front of VOCl3. So there's now 2 vanadiums, so we can scratch out the 1 and put a 2 there. So now the vanadiums are in balance. But what that 2 also applies to is not just the V, it also applies to the O. So we have to change the O to 3. Now why is it 3? Because you have 2 O's in the VOCl3 and you have 1 more in the H2O. So that's a total of 3 oxygens there. So you have to change that to 3. And finally, the Cl3. You multiply that to it. You distribute it all the way through. So 2 times Cl3 is going to give you 6 chlorine atoms there. Cl3, and then you got 2 of those, so that's 6 total atoms of chlorine that you have on that side. Okay, what are we going to balance next? We're going to go ahead and balance the chlorine. So you have 6 on the right, so let's get 6 on the left. So we put a 6 up there in front of HCl. So that 6 not only applies to the Cl, but it also applies to the H. So we're going to change the Cl, we'll change the H there to 6, and we'll change the Cl to 6. So we have 6 on that side. So now we see that the V's are in balance and the Cl's are in balance. So what can we balance next? We have oxygen. Again, we'll stay away from that until last. So that leaves us with hydrogen to balance next. We have 6 on the left and 2 on the right. So if you multiply that water molecule by 3, you now have 3 times 2 hydrogens gives you 6. And now you also have multiplied the oxygen there by 3. So how many oxygens total do you have on the right-hand side? You have 2 in the VOCl3, and you have 3 more in the H2O. So 2 plus 3 is 5. And so that's going to go ahead and put your oxygen in balance. And that'll usually happen when you leave that one till last. It'll usually end up in balance. So we can go ahead and we get the same result as on the last slide. And there's the balanced equation down at the bottom. That's how you balance equations.